get to smarter services? Well, all the services we just saw required an enormous amount of collaboration between public and private facilities. How do we get to that place? Obviously, a lot of this has to do with this applying internet technology and internet thinking to services. That always makes me think of 1995 when Bill Gates famously said, "I don't need to have an internet division. Why would I have an internet division?" He turned 180 degrees off 4 years later when he wrote a letter to all of his employees. That's basically how Microsoft is managed. And he said, "A fundamental new rule for business is that the internet changes everything." An interesting thing to say. Everyone agree with that? Anyone agree with that? I actually think that it's not true, and I'm going to give you an example. But first, let's talk about some examples where the internet has changed absolutely everything, where internet thinking has disrupted markets in ways in which they can never recover, and in ways in which they totally changed. The most obvious one is the one in the upper left-hand corner there. For those of you who are too young to remember, that's a boombox. That's how people used to listen to music. Even before that, there were some other things called 8-track tapes. Yeah, some of you are missing hair, so you remember that. You may even remember the large black discs. I don't remember what they were called. We don't listen to music that way anymore. We listen to music through computers. Those computers might be desktops, they might be laptops. More likely, they're mobile phones or music players. They're small things, but they are computers. Trust me. That's completely disrupted. Most people no longer use physical media at all. In fact, we've seen a similar disruption in television. My adult children, I just learned, don't even realize that you can get television signals over the air, and they certainly don't bother to get television signals over cable. Everything they want to watch, they watch from the internet, legally. Did I mention that? And there are a couple of other examples here: newspapers, book publishing, music creation, and so forth, that have all been totally disrupted over the last 20 years. But I'm here to tell you that there are some markets that have not been disrupted at all. In 1980, I worked on an expert system that could diagnose a failed programmable controller. This device is basically a computer that controlled, this particular one actually controlled a brake lining factory at General Motors factory outside of Detroit, Michigan in the United States. Interesting thing about this, it doesn't really matter what discrete programmable control is, PLCs if anybody's ever been involved, is the inside looks like a computer, looked like any other mini computer of the day, but the outside definitely didn't. And the way that you programmed it was completely different. In fact, that you see to the right of the box is the programming language. I know it doesn't look like a programming language, but it is. It's called ladder diagrams. And more importantly, even though that was what was running the factory floor, there was absolutely no connection between this computer and the computers that were keeping track of the information about the products flowing through the factory. Just-in-time delivery of parts in order to make things, just-in-time output to the next stage in the service or supply chain. That's really bad. That's really bad. In fact, I remember that if you wanted to get information from these boxes and get them to your information systems, you actually had to print it out and then type it back in. Typically with no errors, of course. That's what we call a lack of internet thinking. That is that the information was not connected. The information was dealt with sneakernet, that is by somebody carrying it across the room. In 1980, there was an excuse not to use the internet. Internet protocols were exactly 2 years old. The ARPANET was older than that, about 15 years old, but the internet was a fairly new idea. Something for which there really is no excuse is here we are 35 years later and the same situation pertains. The box has been updated. Rather than this old Massachusetts company by the name of Modicon, it's now a French company with a German name with headquarters in Rhode Island in the US. That's Schneider Automation. The box looks a little different, as you can see. I think it's plastic now instead of metal. Instead of being called a 584, it's called a 984. But the most important things are it's still programmed in a completely different way than other computers. And it's still integrated with the other computers in the plant in exactly the same way. That is to say, not at all. There is an Ethernet port on that box. You probably see it there. But it doesn't speak internet protocols. There's still a lack of internet thinking in that marketplace. In fact, there are many markets where there's a lack of internet thinking. I'm not going to go through all of them in the short time I've got, except to say, in oil and gas exploration, in fact, all this morning yesterday morning we were talking about oil and gas exploration and how the fact the upstream market has basically not changed from the information standpoint. In rail and other transportation, there's a lot of data being collected, but it's not actually being used. One of my favorite presentations was a General Electric presentation. A General Electric executive by the name of Stefan Brungart was saying that General Electric diesel-electric locomotives actually collect 9 million points of data every second. And I said, wow, that's amazing. How much of that data is actually used? And he said, 3. And I said, that's not bad, a third. He said, no, 3. The point is, we could do a lot better. We could build the kind of services that Dilip is talking about in lots of different markets, not just city services and national services, but and not just home automation, which gets talked about a lot in the IoT space, but in oil and gas exploration, in power generation, distribution, and transmission, in factory management, and so forth. What's lacking is that internet thinking, and that's what we have to do, is take the internet revolution and add it to into the industrial revolution. To be specific, late 19th century, we had something called the Industrial Revolution. The Industrial Revolution created an enormous leap in productivity, somewhere between 2.5 and 4 times, depending on which economist you don't believe. I don't believe any of them. There was a disruption, by the way, right? So if you've read any history about the Industrial Revolution, you know that that movement of human brawn to machine brawn actually created huge social disruption. In Germany, there was a group called the Webers. In the UK, there was a group called the Luddites that went around trying to destroy these new machines because they were destroying jobs. And they were destroying jobs. The reality is far more jobs were created than destroyed, not just for the new technology, but because this enormous leap in productivity created more consumer demand created more opportunities, and there were actually far more jobs created than destroyed. But that disruption is something to watch. We saw this happen again in the late 20th century with the internet revolution, the move of human connectivity to machine connectivity, not really thought. Again, an enormous increase in productivity, again between 2.5 and 4 times depending on the economist. If we take this kind of internet thinking and we add it to industrial systems, like manufacturing systems and healthcare integration systems and financial systems integration, I think you can do something that we call the industrial internet. There we go. The industrial internet, and that is internet thinking applied to industrial systems. Why would we do that? Well, basically because the measurable outcome will be enormous. I don't like to present just one analyst's numbers because only Makina Research's analyst numbers are any good. General Electric calls it a $32.3 trillion impact on the world GDP. This is actually a good report worth reading called The Industrial Internet, written by Marco Annunziata, published in 2012 by General Electric, analyzing the $70 trillion world GDP in 2012, and finding that about 46% of that GDP could be affected by applying internet thinking to industrial systems. That's $32.3 trillion. If you can get a 1% swing in $32 trillion, that's a mere $300 billion a year. Not bad, worth going after. Cisco calls it a private sector profit increase of 21%, $19 trillion to the world bottom line in 2020. You can read these numbers as well as I can. Gartner and McKinsey. I should have Makina's numbers there, sorry, but you can tell us later. The bottom line is whether you call it the industrial internet of things, which we tend to call it, or industrial internet, whether you call it Industry 4.0, which is what it's called in Germany, whether you call it the Internet Value Chain Initiative, which is called in Japan, or Internet Plus in China, or Industrie du Futur in France, it's all the same thing. It's this pattern of collecting information from a large number of sensors, potentially planet-wide, doing real-time predictive analytics on those sensors, and then directly having impact on actuators or providing decision support in the form of visualization to decision makers. You actually just saw a whole bunch of examples of that in Dilip's presentation. His sensors are Dubai-wide, and there are tens of thousands or maybe even hundreds of thousands of sensors. Now think of systems that will be millions or tens of millions of sensors and planet-wide. How are we going to get there? How are we going to get to the point where we can get all these systems collaborating? It was probably a little bit easier in Dubai. I wouldn't say easy, but easier, because there were orders from above saying you're going to integrate these systems, and we are going to make sure that's going to happen. The reality is, in the rest of the world, however, or if we're integrating systems across banking and healthcare and mining and manufacturing And you need your technology vendors and your big data vendors and your security vendors and your research organizations and your academic organizations to work together. They're not going to build all the appropriate one-on-one relationships in order and fast enough to make a market appear. So our idea is bring them together into what we call the Industrial Internet Consortium to work together to figure out what needs to be done. At this point, somebody says, well, we could go back to the poll, but I suspect it says what it normally says, and that is that the two things you really have to provide are security and interoperability. I'm sure we'll talk about security a couple of times over the next hour or so. Interoperability you best achieve through standards. As the chairman and CEO of the world's largest standards organization, that's something I actually care about. But the reality is, in the Internet of Things, we don't necessarily know what standards are necessary. The previous panel, they talked about standards like 3GPP for devices, for wireless devices, but we're not just talking about wireless devices. A lot of information that's in a manufacturing plant or in a copper mine, for example, is wired. Wireless is not the problem. The problem is, how do we collect information from different vendors' devices? How do we correlate information with different correlation engines? And how do we have output to actuators that are from different vendors and use different standards? That's the reality. So you've got to get them working together, and you've got to get them working together to build what we call test beds. So that's our mission statement. Don't read the whole thing. The last 3 words are the most important, and that is transformational business outcomes. If you want to create a market, figure out what's going to be disrupted. And what you need is companies that realize that their markets are going to be disrupted and would rather disrupt those markets themselves than wait for others to disrupt the market for them. It's always better to cannibalize your own product rather than have somebody do it for you. 5 companies got together about 18 months, almost exactly 18 months ago, to create this organization: AT&T, General Electric, Cisco, IBM, and Intel. So that's 2 users of the technology and 3 manufacturers of the technology, and said, let's test bed these ideas. Let's see where the transformational business outcomes are. Let's see where the new business models are going to be, what they look like. We thought that today, 18 months later, we would have about 2 test beds running and we would have, say, about 80 or 90 members. In fact, today there are 220 members and 12 test beds running. I'm going to briefly talk about some of them. These are some of our large company members. Besides the 5 founding members, 2 other large companies have joined as contributing members, SAP and Schneider Electric is the parent company. It's worth noting that on this slide you'll see not just technology vendors, but as I said, there are automobile manufacturers like Toyota. There's the world's largest copper mining company in the upper left-hand corner, Codelco. There are manufacturing companies, there are mining companies, there are in fact banks, there are HVAC manufacturers, there are film and healthcare device manufacturers, a lot of companies that realize their markets are going to be disrupted. The way they sell things is going to change. The impact on them is going to be enormous, and they'd rather disrupt themselves than wait for somebody else to disrupt them. That also means you need to have the small players with innovation and innovative ideas participating. 55% of our members are small companies, that is under 50 million US in annual turnover. These are some of them. Again, though they're not all technology vendors. You actually see some small manufacturing companies there, for example, networking companies and so forth. And don't forget the academic participants. We have about 24 academic and research organizations that are participating from all over the world. There are organizations from about 28 countries today, and standards organizations as well. These are organizations that have agreed, both standards organizations, by the way, and open source development organizations, to take requirements and priorities from us and deliver standards so that we get reliability, security, and interoperability through standardization.